Hey guys, welcome to another video. In this video, I want to solve the system of linear equations by using Gauss-Jordan elimination, okay? Actually, these equations involve two equations with two variables, so we can use other methods like substitution, comparison, elimination, Martin's rule as well as Cramer's rule. But here I want to use Gauss-Jordan elimination, okay? Therefore, let me express this first into matrix form, which is 3, -7, 1, 5 times the matrix x, y equals to 11, -3. This is the product matrix, okay? Now, in Gauss-Jordan elimination, we have to express this in this form, like 3, -7, 1, 5, and this product 11, -3, okay? Now our job is to modify this matrix, okay, by using elementary row operations, which means we can divide or add or multiply, or we can subtract the rows and columns and perform operations on this matrix such that this matrix reduces to our identity matrix, which is the form 1, 0, 0, 1, okay? And when it gets reduced, we also have to change this product matrix, right? So our product matrix will be something new matrix, okay? As soon as you succeed in changing this matrix to the identity matrix, then this number, where we will have this number, so it will correspond to our x and y values. So this is our main goal in performing elementary row operations and the Gauss-Jordan elimination method, okay? Now let's start our work. So we have that first, to get this one, what we will do is we will divide this, okay? We will divide the row 1 by 3, okay? If you divide this, then we will get 1, -7 by 3, and here product will be 11 by 3, and we didn't perform operation on row 2, so our row 2 will remain as it is. So 1, 5, -3, okay? Now our next goal is to change this element 1 into 0. So we can succeed this by just subtracting the row 1 from row 2, right? So if we subtract 1 minus 1, then we will get 0. So what I will do is I will take row 2 minus of row 1 plus row 2. I will add to row 2. So we'll get 1, -7 by 3, 11 by 3, right? And row 2 will change to -1 plus 1 is 0. And we also have here negative of -7 by 3 plus 5, right? So it will be +7 by 3 plus 5. It will be, so 15 plus 7 is 22 upon 3. So it will be 22 upon 3. And we also have to change this. So we have -11 by 3 row 1 plus, here minus, so -3, which will be 9. So 9 minus -9 minus 11 is -20 upon 3, right? So we'll get -20 by 3, okay? Now our next goal is to change this element to 1. So how can I do this? If I multiply row 2 by 3 by 22 of row 2, then it will change this into 1, right? So our row 1 will remain as it is. So 1, -7 by 3, 11 by 3, 0. So it will be 1, and we have to multiply this with 3 by 22. So we will have -20 upon 3 times 22 upon 3. So we'll have -20 upon 3 times 3 by 22, right? So it will be -20 upon 22. So it will be, so -10 divided by 11. So our answer will be negative 10 by 11. Okay. Now our last thing is to change this to 0 here to correspond to this. So in order to change this to 0, what I can do is I will operate this row 1 by taking 7 by 3 of row 2 and adding to row 1. Okay. So by doing this, we will get row 1 is here, row 2 is 0 plus 1 is 1. And here 7 by 3 times 1 is 7 by 3, minus of 7 by 3 is 0. And here you have to change this. So I will get 7 by 3 negative here 10 divided by 11 plus 11 by 3, right? So I will get 70 negative 70 by 33 plus 11 by 3, which is that I will get 33. So 3 times 11, right? So 11 is 121 minus 70 upon 33. So I will get 121 minus 70 is 1251, right? So I will get 51 upon 33. Okay. So here it is 51 upon 33 and 0, 1, negative 10 by 11. Okay. Therefore, we have finally succeeded in changing this matrix, the previous matrix here, or the identity matrix. Therefore, this will correspond to x and this will correspond to y. Therefore, our value of x is 51 upon 33 and value of y is negative 10 upon 11. Okay. Now, if this is correct, then it should satisfy both of the equation. Okay. Now to check the equation, what we have to do is we have to substitute this value of x and y and see whether it satisfies both of the equation. Okay. Therefore, what we will do is we will take this equation first. We have x plus 5y equals negative 3. So we have x plus 5y equals to negative 3. So upon substituting these values, we have to get negative 3. Okay. So we have 51 upon 33 minus here minus 5 times 10 is 50 upon 11 equals to negative 3. It should give negative 3. So we will get 50. So we will get 51 minus 11 times 3 is 33. So 50 times 3 is 150 divided by 33 should be equals to 3. So it will be 51 minus 150 is negative 99 upon 33, which will be negative 3. Therefore, it satisfies the second equation when we plug in x equals to this and x equals to this, y equals to this. Okay. Now we have to also check for this equation. Okay, 3x minus 7y equals to 11. So we have 3x minus 7y equals to 11. So we have that 3 times 51. So 3, 15, 153 divided by 33 minus, and minus is plus. So 7 times 10 is 70 upon 11 should be equal to 11. Okay. So it will be 153 plus 11 times 3 is 33. So 70 times 3 is 210 divided by 33 should be equal to 11. So it will be 3, 6, 3 upon 33 equals to 11. So I think that therefore we have to say like 33 times 11 should be equals to 363. Okay, so we will get 3, 3, 3, 3. So it will be 3, 6, 11 equals to 11. Therefore, when we plug in x value of this one and y value of this one, it satisfies both of the equation here. Therefore, our value is x equals to 51 by 33 and y value is negative 10 by 11. So this is how you solve by using the Gauss-Jordan elimination. And it is not only limited to the 2 by 2 matrix. It can solve 3 by 3 matrix, which is 3 equations involving 3 variables, 4 equations involving 4 variables, up to n equations involving n variables, n number of variables. Okay, I hope you have understood and really enjoyed this video as I did while making this video. So I'll see you next video. Thank you.